In this part, we will look into storage devices and file system interface provided by the operating system. So, in the memory hierarchy of a system, disk is at the bottom, where the hierarchy is decided by the speed with which the memory can be accessed. So, registers are at the top of the hierarchy because it takes almost no time to access registers, and cache takes a bit more time. Main memory takes a bit more, further more time, and then disk is the slowest memory, and it is at the bottom of the memory hierarchy. And one advantage of disks is it's persistent. That means the data we store on disk is persistent across system reboots. So, how is data stored on the disk? So, for according to the users, when we use the disk, we see just files. So, according to user, files disk is just a bunch of files that are stored. Okay, and each file has a name, and in principle, each file is just a sequence of bytes. However, when you look at a disk drive like hard disk, it's just a piece of hardware. So this is the picture on the slide shows a magnetic disk, the regular disk. So here, as you can see, it has various electronic components, and it has platters, spindles, and various other electronic devices. So how does data get stored on this electronic equipment? So if we dig a bit deeper, so the center part is the magnetic disk. So here, when you actually look more deeply into the center part, what you will see is a stack of platters. So these are magnetic platters, and each platter has various concentric tracks. Okay, and each platter is also divided into sectors. And we have a disk head that uh, reads contents on these platters. So the platter, the data can be stored at the both at the top and bottom of a platter. Okay. So how does data get stored? Like how does data, which is just zeros and ones, get stored on these platters? So the data is stored by writing small, like very micro uh, dots on the disk platter. So each dot, each magnetized dot represents zero or one. Okay. And there are millions of dots on the surface of each platter. And the unit of access is usually 512, that's called block size. It's either 512 bytes or 4K, which is like the page size bytes. So this says that like the amount of data that you can atomically access from a disk is in terms of blocks, where like you can either access like the entire block or you cannot access anything. Okay. So the block size is usually 512 bytes or 4K, although I think most of the modern disks, the block size is 4K. Okay. Now we see files, according to the users, is just a sequence of files, whereas on the disk, these are just magnetic dots, right? So we need a way to map the files that a user sees to the hardware or to the magnetic dots that we use to store. This is where the file system abstraction or file systems come in picture. So file systems takes care of translating the files in and out of this hardware. So file system keeps tracks of each file, and it also makes sure that the file data is actually translated into magnetized dots and stored onto the magnetic disks. Okay. So in order to do that, what does a file system needs to store about a file? We call this file metadata. In addition to the data for each file, a file system also needs to store some information about a file, specifically its file name, because that's how we access it. And then permissions, we'll see later what permissions mean. And file system also needs to store like who is the owner of the file, who's the group, what is the group of the file. It also needs to store the type of the file. And finally, it also needs to store all the disk blocks that belong to the file. That means it also needs to know where on the disk does the file data contains, right? And along with that, it also file metadata. There are other things that file metadata usually contains on modern operating system. So file metadata, note that file metadata is not exactly the data of the file that we see. It is the data maintained by the operating system in addition to the data that is stored on the file. Okay. So the file data is called data blocks, or like disk block, data blocks, which are stored on different disk blocks. However, file metadata is the additional overhead or like additional management data that a file system stores about a file. And the structure in which file metadata is stored is called inode, which stands for indirect node. So each file can can be composed of one or more inodes. Okay, so a file system maintains all the inodes for each file, and a file can there could be multiple inodes corresponding to each file. Okay. And where are these inodes stored? Again on disk, because as I mentioned before, the data stored on the disk is persistent, right? If inodes represents the metadata of the file, we better store the metadata again on the disk as well, so that when the system reboots, we should be able to uh, restore the file system. So inodes are also stored on the disk. So usually what happens is a portion of the disk is usually dedicated to inodes, so that we know exactly where to go in order to list the files or in order to get the files. Okay. So, and file inode, a typical structure of file inode is as shown on the slide. So the inode structure usually changes with different file systems. However, the common, like one of the common structures of file inodes is as shown on this slide. So here there are various fields in file inode, and then at the end we usually have pointers called file block pointers. Okay, these are pointers to the blocks, the disk blocks that contain data for that file. And this is the user data. So here, as you can see, we have various single blocks like block 0 to block 5. And at the end, we have pointers to indirect block and then doubly indirect blocks. So these are like, these provides additional indirection. So imagine when you have file size of, let's say, 4 gigabytes, and each block size is of 4K, then you need various blocks to store the file. So if you maintain a single list of blocks, then you cannot store all the blocks. So that's why you create the operating system maintains like indirect blocks, doubly indirect blocks, so that we can easily expand the file size without actually changing the file inode structure. And what are like another thing that is important for each file is file permissions. Okay, these indicate how a file can be accessed by the user or by various other entities. So what are the types of accesses that we can do on a file? We can either read a file, write a file, or execute a file. Okay. And who can access a file? Either the owner, or like the user who created the file, or the group to which the file belongs. So group is a tag, and it's given to various users, and it allows us a way to group multiple users. Okay. So for instance, on Linux, you must have heard of sudo group. So sudo group is the group of users that have uh, privileged access or root access. And others indicate all the other users who are like the users who are not owners, or who are not part of the group of the file. Okay. So there are three categories of users who can access the file, and there are three types of accesses that any user can make onto the file. So in total, we need 9 bits to represent the permissions of a file. So these are represented by using a bit pattern. So which you can usually see when you do ls minus l. You usually see the bit pattern at the first column. So for instance, you must have seen like RW hyphen RW hyphen R hyphen hyphen. Okay. So here the bit pattern, like if you convert the bit like 3 bits into corresponding decimal, so you see that the first bit pattern represents 6, second bit pattern represents 6, and the third bit pattern represents 4. So these are the permission for the user, that is the owner of the file, and the group, that is the group that belongs, that the file belongs, and then for the others. So these 3 bit patterns, they represent the permissions on the file given to each of the corresponding entity. Okay. So first 3 bits are the permissions on the file that are allowed for the owner of the file, and the second 3 bits are the permissions, or like the accesses that are allowed for all the people who are not users, who are not owners, but who are part of the group of the file. Okay. And finally, the last 3 bits indicate the accesses that are allowed for all the other users who are not owners, or who doesn't belong to the group of the file. And you can change the permissions of the file. Operating system provides a system call called chmod, using which you can specify the bit pattern and change the permissions of a file. So how these inodes are stored, as I briefly mentioned before, we have a fixed location on the disk where the inodes are stored. Okay, so usually what happens is the disk has fixed size, and then the variable disk data blocks. So here, super block is a fixed block that every disk that is present at the start of the every disk. So it contains magic, which indicates the type of the file system, and then number of blocks of the disk, and the blocks that represents the inodes, and finally the inode bitmap, basically the inodes that are free inodes that are allocated. So, and then after super block, we have a bunch of space that is allocated for inodes. So here all these blocks are inode blocks. They are dedicated just to store inodes. And then we have data blocks that will be pointed by the inode blocks. Okay, so this is how inodes are stored. So when you boot the machine, what happens is the operating system boots up, and it will just read the super block. Super block will tell an operating system how to interpret all the data on the disk. Then once it reads the super block, it knows the inodes. It knows all the inodes. So it loads the inodes. Once it knows the inodes, it knows all the blocks that contain data of a file. So that's how file system gets initialized in operating system. So, and how can you access file system from user space? Operating system provides various system calls like create to create a file, open, read, write, stat to get attributes of a file, and so on and so forth. There are various system calls, like almost 18 system calls provided by the operating system, which allows users to do various operations on the file. So in the next part, we will look into directories and some special files that helps us manage file system more efficiently. Thank you.